So I just want to illustrate how sometimes changing the scale on your flow cytometry data can lead to misleading representations of your data. And so here we've got a plot with a fairly typical distribution with a clear negative population here, a very well separated positive population over here. We've drawn our quadrant gate to reflect where we think negative and positive lie. And let's see what happens if we transform the scale. So we're going to transform the x-axis here. I'm going to add an extra negative decade. And I'm going to change the width basis here. And watch what happens to this negative peak here when I change the width basis. So you can see that it now appears as if there's two peaks with an anti-mode in between them here. Let's apply that. And so we know that the positive is over here because we can see that clear population. But if that wasn't there, we might be tempted to interpret this data differently and say that this is our positive and this is our negative here, just based on the way the data look. But something that should give this away as being incorrect is that the division between these populations where we've put our gate is very close to 0. That should send up a warning because you would not expect a flow cytometer to have any kind of resolution at this level of the scale. This is the area where the differences in signal here are just dominated by noise and random fluctuation. Let's reset the scale and see how our gate looks. And you can see that where we place the gate there just bisects this population. Now, in this plot, we wouldn't really be tempted to change the scale at all. But sometimes when we're trying to find a representation of the data that makes it easy to interpret, it might be perfectly valid and helpful to change the scale. Let's have a look at another channel where that might be more tempting. So in this channel, we don't see a clear positive. And in order to sort of try and make sense of this data, we might be tempted to change the scale. So let's go ahead and do that. So we're going to add an extra negative decade again and increase this width basis. So again, you can see that that's done the same thing, and we can see these two peaks here. We might be tempted to add a gate between them and call this negative and that positive. But you can see the division between these two populations is actually below 0 here. And so we know, because that's below 0, that that's not a valid interpretation of this data. Now, I'm not saying here that it's never valid to change these settings, to transform your data differently, but you should be very careful doing so that you're not making a view of the data that is misleading like this. And the thing that really you should be paying attention to mostly is where on the scale you're putting a division between negative and positive, and that if that division is very close to 0, then there's probably something wrong.